Namaskar students. In this video, we will see how to calculate the HCF of two numbers using Euclid's division algorithm. For this, I have taken one example. Use Euclid's algorithm to find the HCF of 288 and 78. So we will see one by one. First, we will calculate HCF by long division method. In this method, the larger of these two integers, we have taken it as a dividend. So 288 is larger than 78. We have taken it as a dividend, this as a divisor. So we can see in this long division method, which we have already learned in lower classes. So we can see in this division method 78 goes into 288 three times, leaving remainder 54. Since the remainder is not equal to 0, so we have to continue this division until we get remainder as 0. So now how will you continue this division? In this, the remainder will become the new divisor and this 78 will become the new dividend. Now we can continue with our division. So 54 goes into 78 one times, leaving remainder 24. Again, remainder is not equal to 0. So 24 will become the new divisor and 54 will become the new dividend. Now we can again see the division process, that 24 goes into 54 two times, leaving remainder 6. So again the remainder is not 0. So we take 6 as the new divisor and 24 as the new dividend. Now in the last step, we can see 24 is completely divisible by 6. So and we are getting remainder as 0. So the HCF of the given numbers is what? 6. So we are finding the largest number which is divisible by, which divides these two numbers. So the largest number which divides these two numbers is 6. We can see these two numbers are divisible by other numbers also, like 1. 1 is a factor of each number. These two are even numbers, so they are divisible by 2 also. We can check the divisibility rule of 3. If I check divisibility rule of 3, so if I add all these digits, this would be 18, this would be 15. So both are divisible by 3 also, but we are searching for the largest number which divides these numbers. It is 6. So this process is known as successive division method. Why? Because we continue the division until we get the remainder 0. So this process we have already been taught in our earlier classes. Now we move on to the next approach, which we will learn in this case, that is HCF using Euclid's division algorithm. Now see, algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Now algorithm is a computer term. Now we can say that when you are solving a problem in some steps, these steps are the part of algorithm with some condition. Now these two methods are exactly same, but we are solving the problem in steps here. And here we have a traditional method of solving this method by division method. Basically, we are calculating HCF by division method. So here we are doing in steps. Now see, in this algorithm, we are using Euclid's division lemma. If you remember, Euclid division lemma is same, dividend equal to divisor into quotient plus remainder, or we can restate in form of lemma, that is A equal to BQ plus R. Now see this first division, here we can apply Euclid division lemma. This is A, this is B, this is Q, this is R. So in the very first step, we can write that 288 is equal to 78 times of 3 plus 54. Now when you 78 multiply 3 is 234 plus 54 will become 288. So we have applied Euclid division lemma, but here the remainder is not equal to 0. So we have to check the condition here, because algorithm works with the condition. So if the condition is true, so we will move on to the next step. So the next step is what? In the next division, the dividend is 78, divisor is 54. This is A, this is B. So 78 can be written as 54 times of 1 plus 24. Again, the remainder is not equal to 0. The condition is true. So we will move to the next step and we are writing this step. This is the third and this is the fourth step. It means in long division method, if we have 4 steps, it will complete it in 4 steps. So 24 is equal to 6 into 4 plus 0. So here we can see the last divisor is 6. So whichever is the last divisor, that would be the required HCF of these two numbers. So I hope you understood this Euclid's division algorithm using Euclid's division lemma. So